I learned from States that you really need to incorporate my blocks into all your programs instead of just using regular move blocks and turn blocks. It's really important that you incorporate my blocks.
This year we used a more advanced programming technique called my blocks. What a my block can do is it can take a large program and condense it into one small brick. As you can see on this brick here that I'm highlighting with my mouse, it is a line follow brick, this brick right here. And as you can see, it is very small. And if I open it up here, you can see that the actual program inside it is much bigger. Slowly, there it is. And here's the program that was inside of that my block, condensed all into one little brick. As you can see, as you can tell, the my block saves us tons of space in our program, and it allows us to modify large programs much easier than we could before.
We learned about math blocks. We use math to change the rotations to amount of centimeters. So we just measure and we plug it in how many centimeters we need. We did that with our turns too. We put rotations of the motors for turns and we put it into degrees. We put all that math strand into one my block, and you can add variables where you can use data wires to connect it, and all you have to do is plug in a number and it does all the work for you. And it shortens your programs a lot. It makes them very simple.
Alright, this brick here, as you can see, it is in our program. This is a math block. We use these blocks to perform advanced functions that our robot couldn't normally do alone. As you can see, if we plug up this value to A and this value to B and set this to subtraction, not division, but subtraction, it will take the reading from this block and subtract the number from here from it, and then the equals, whatever the answer is, it comes over here and it's plugged in for B, which is multiplied by this, which is a constant block. And this constant block works hand in hand with the math block. And with the math blocks and constant blocks, your robot can perform much more complicated tasks than it could without them. This year our team motto is feedback. So as you can see in our programs, we have a line square brick right up here. And what the line square brick will enable us to do is, with our two color sensors, we can come up to a line, and if our robot comes at an angle, it can square itself up to the line to make our programs more accurate. Also, in other parts of the program, we use line follow bricks, which allow our color sensors and our robot to follow along lines to also further our repeatability. And also in our programs, we use an ultrasonic sensor, which can read distances from walls and mission models, which can also help our robot know where it's at on the board to once again increase our repeatability.
So this is our run one. All these blue blocks you see here are my blocks. Sorry. So each one of these has a special purpose when you open them up. This up here is what you would do when you open up the move block. This is our constant. We get that by calibrating, then dividing our calibration by 1,000, and that's our constant for how many rotations our wheel moves in one rotation. This is run 2. And it gets the car motor, the methanes, the bag, compost, turtle, toy. This is our biggest run. And all these blue blocks are the my blocks, and they're all controlled by math blocks. So say you wanted to open up the line square. You would double click on this and it would open up this one. Now this is our math blocks. This is what happens when this math block is made into a my block. So this is the first weight, and you see all these little lines connecting everything. So this is the right motor and this is the left motor. It tells it that this needs to square up on the line and wait for however long you enter the constant in for the regular block of constant weight on here. See, you can see the wait for 0.2. So that's what's going to tell these two motors to wait for that amount of time until These right sensor and left sensor sees the black line and stops and waits. This is our flow 3, and what it does is it goes forward until it line squares, then turns left, and then it uses the right color sensor on our robot to find the black line, and then the ultrasonic kicks in. What you see here is this is a medium motor, and I'll zoom in so you can take a look at that. And what this does is it tells our dog ear attachments to go up or down at how many rotations to pick up things or drop. And this is what is dropping the methane and picking up the bag with our turntable. In this run, we use the robot to drive forward until it line squares. Then it moves and turns right to drop the animals into the big circle. Then it moves again and turns backwards left. Then goes straight forward until the truck is east of the transfer.
This is our favorite program this year, and what this program does is it tells the robot to drive forward, and skipping through here, a line follows. It will drop the engine into that car. It will pick up 2 of the little methane mission models, hit the composting button, grab the animal in the plastic bag, then return to base. And this is the program that we wrote for it. As you can see, the little blue blocks in here are my blocks. Without these my blocks, our program may be this long. It's hard to tell. The my blocks condense our program and make it so much easier to create, because with just a simple change of a number from calibration, we can make sure our programs work no matter what kind of board we're on and with any wear and tear on our motors.